Next up, related to networking services, is Cloud NAT. This entire presentation on Cloud NAT will be relatively brief, just basically an introduction, but we will cover the relevant points for the exam. So first, NAT stands for Network Address Translation. It's a technology that is used to map private IP addresses to public IP addresses, and that enables communication with external networks. Cloud NAT, the GCP service, correspondingly allows compute resources without public IP addresses to access the internet for outbound connections. Usually the compute resource in question is a VM. So Cloud NAT is useful for maintaining the security of your resources by keeping them private while still enabling necessary internet connectivity. That's the whole idea. Let's go over an architecture with Cloud NAT. So first we have Project A, which contains a VPC network named VPC Network A. Within this network, we've created a subnet labeled Subnet A1, which is where your VM instances reside. So we have two VM instances, and notice that both of them have internal IPs only. There are no external IPs assigned to them. This means that by default, they cannot reach the internet directly. To allow these VMs to access the internet for outbound connections without needing external IP addresses, we set up Cloud NAT at the VPC level. Cloud NAT serves as a central managed NAT gateway for this VPC network. It handles outbound traffic for resources in our subnets. And when one of these VM instances initiates an outbound request, such as to an API or an external service, what Cloud NAT does is it translates the internal IP to a public IP, hence network address translation. This translation happens seamlessly. So Cloud NAT takes the private IP and maps it to a single public IP that is assigned to the NAT gateway itself. After translation, the request from the VM goes out to the internet using the NAT gateway's public IP address. And when the response comes back from whatever they were accessing on the internet, Cloud NAT also handles that seamlessly. The public IP that is used for the outbound request receives the response, and Cloud NAT maps it back to the original internal IP of the requesting VM instance within the subnet. So this way, the VM receives the data as if it had directly communicated with the internet, and Cloud NAT maintains this mapping through the session, ensuring that each response reaches the correct VM instance without any additional configuration. This process allows for efficient and secure bidirectional communication, which allows VMs to access those external resources while keeping their private IPs and thus being shielded from direct exposure to the internet. So as an FYI, as part of the setup of Cloud NAT, you do select the subnet whose instances are eligible for translation, and that is done in the Cloud NAT mapping section of console. So that could show up on the exam. But anyway, with this architecture, you've got secure and cost-effective internet access for VMs in your private subnet, and so there's no need for individual public IPs on each VM instance. There are several available source endpoints for Cloud NAT in GCP, not just VMs, but we're going to go through the ones that are available. A source endpoint in the context of Cloud NAT refers to the resource within a private network that initiates outbound internet traffic and relies on Cloud NAT for secure and private connectivity. The most common source endpoints are VMs without public IP addresses. We just discussed these in the previous slide. So they're compute engine virtual machines that operate exclusively with private IPs. And we saw an example of them in the previous slide. Next, in the center, we see private GKE clusters. That's another option. They are configured, these private clusters are configured so that their nodes only have private IP addresses. We covered this in the GKE section, so go back and review that if you need to. But they only have private IP addresses, and that keeps them isolated from the public internet. But the workloads running on these clusters often do need to pull things like container images or other dependencies, communicate with external APIs, send telemetry data. Cloud NAT enables these clusters to access the internet for such tasks while keeping their nodes private. And on the right, we also have serverless services that are connected to a VPC subnet. So this includes services like Cloud Run, Cloud Functions, App Engine, Dataflow. These services do not directly integrate with Cloud NAT, but the VPC subnet that they are connected to acts as the source endpoint. So Cloud NAT allows these serverless workloads to communicate with external resources securely and without requiring public IPs for the subnet. But it just kind of operates a little bit differently. We don't need to go into detail about that yet, but it is something that could show up on the exam in the sense that, you should know that a serverless service using Cloud NAT does not automatically disqualify that answer choice, because it is possible. So these are the source endpoints that Cloud NAT could be used with and that you might come across on the exam. Let's just cover the benefits of Cloud NAT so that you understand the usefulness of it and the context. Cloud NAT reduces the attack surface by eliminating the need for external IP addresses on VMs to access the internet, right? So that prevents unsolicited inbound connections, makes your environment more secure, and limits potential entry points for attackers. Another benefit is that it scales automatically. So as the number of VMs grows or the volume of network traffic increases, Cloud NAT can adjust to handle that without manual intervention. This is a common thing we see among GCP services, especially managed ones. They scale automatically. Well, that applies to Cloud NAT as well, so just know that. And then it's also designed for high availability. It has no single point of failure. That means that it can provide reliable connectivity for your workloads with minimal risk of downtime. And it helps to lower costs by reducing the number of external IP addresses needed. So external IPs, they do cost money. And since Cloud NAT enables private access to the internet, you actually don't need to allocate public IPs to individual VMs. And that can result in cost savings down the line. This slide shows an example scenario where Cloud NAT is particularly useful. Imagine an organization has implemented a strict organization policy disallowing external IP addresses on VMs. This is where Cloud NAT becomes useful. Cloud NAT enables outbound internet connectivity, as we said, for these VMs with private IPs, which must have private IPs because they are adhering to the org policy. So we talked about org policies early in the course. Cloud NAT is commonly used with this org policy. This is the kind of scenario that could show up on the exam. Activating Cloud NAT often goes hand in hand with disallowing external IP addresses through this org policy, compute.vm external IP access. Okay, that was our introduction to Cloud NAT.